Welcome to Let's Code. I'm here with Thiago. Hello.
Hello, John.
One of my more senior students here at BIT and a regular on Code Club. You'd be familiar with his voice if you've binged watched that series. So thank you for joining me today to work on the lunar lander. I'm feeling excited about it. I feel we're very close to getting back to a working game. So as you know, we started with a working game, or we prototyped a working game, and then we said, let's be software engineers, let's turn it into a package and add tests and refactor a bit, and then we can get onto our fun stuff like fuel, graphics, multiplayer, whatever you like. So, what do you think? Are you up for helping me get this back to a working state?
Yeah, let's try.
And then we'll see what we can do. So essentially what we've been doing is, we started out with all the code in main driven development. Once we were happy with that, we started moving it into functions inside the lander package, which we can test. Here's some of our tests. And the first thing to do was we need some concept of a game object, so that these things aren't just globals. We have, we could imagine an online game server, can't you, where everybody can play the game in their browser or something.
Mm-hmm.
So there may be dozens of games going on simultaneously in this program, each with their own state of the world, so that's why we have a game object. We have a constructor for it. So create a new game, ready to play. Next problem was how to show the player what the current state of the world is. So we've got a display state method. Naturally enough, that takes an IO writer to write to. In the real game, that's OS standard out. In the test, it's our old friend bytes buffer, pointed to bytes buffer, so that we can look at it. Same idea for read thrust, so the player has to have some way to control the rocket. So that's now become a read thrust method on the game. It takes an output writer again, but now it also needs to take an input writer, doesn't it? Input reader. In the real game, that's standard in, so you type on the terminal to enter your thrust setting. In the test, though, no surprises, it's a bytes buffer with some input that we stuffed into it, and actually that doesn't need to be 10.0, just 10. Excellent. So we're about halfway there, aren't we? And we said, and the next bit is basically we've shown the player the world, we've got their control input, and now the last thing to do in this game tick is to update the world based on physics, isn't it?
Mm-hmm.
Now, neither of us are professional physicists as yet, but we can do everything we need to do, can't we? Which is the rocket's altitude is going to change based on its velocity.
Mm-hmm.
That velocity is going to change because gravity is a thing. And we also have a rocket, luckily, otherwise we'd just hit the moon very hard.
Mm-hmm.
So that also updates the velocity. So we imagined last time pushing this into a method called something like UpdateWorld.
Mm-hmm.
Name TBD, but here comes the science bit. So let's complete that. So actually, should we do a test? That would make sense, wouldn't it? Test update world.
Sounds good.
We know how to write tests because we're from BIT. So let's be parallel. Always a good start. What should we think about next?
Before we start, just want to comment in the root trust. Don't care about error. Should we add Y?
Yeah, we could. I'm sorry, it's too late to bike shed that method. We did that last week. No, but the point is, when we did the game object refactoring, now each of the tests needs to call new game to get a new game. Now we actually have a test for that, where we say, right now, actually, new game can't error. Because it doesn't take any inputs, it doesn't do anything which could have a runtime error, like opening files or whatever. But we're putting that in as a placeholder for the future. So we're saying, we can imagine that new game takes some configuration, for example, difficulty setting, initial values, whatever. And those could be wrong. So we want to return that error to validate them. Now in new game, we naturally want to test that error is not nil with valid inputs. That's part of its public API. And we would and when it can return error, which it can't at the moment, we would also want to exercise that in the tests. Now other tests also need to call new game, but in fact we know we're going to give it valid inputs.
Yep.
Or we hope we are.
I got it, but for a new person read the code, maybe we should don't care about error because it's being tested by the test.
Yeah, exactly. The point is, this is not a test for a new game, so it's not, we can think of this as like, this is test code. It's testing the public API of new game. This, if we had the same thing in this test, it would not be test code, just normal Go error handling, like we tried to do something and it didn't work. So whatever. So actually I don't really feel good about that at all. I think we should just check the error, shouldn't we? As you rightly said, it's just confusing if you read the code and you see that and think, oh, why don't you care about the error?
Yeah, or just say the reason. I'm okay with both, to be honest.
Yeah, it's a useful little thought process to go through, though, isn't it? So the first one of the many commandments of BIT, which I need to get inscribed on a stone slab, is thou shalt always check errors, right? So very occasionally we don't need to check errors. So we could use the blank identifier, but another commandment says, if thou usest the blank identifier, thou shalt always comment to explain why this is okay. Like there's some assumption that we're making, which at the moment is implicit. It's just saying we know we're always going to call new game the right way. So we could actually say that and then it's like perfect. We broke one commandment, but we saved ourselves by obeying the other one. But actually the fact that we've done that kind of says, you know what, if we're going to have to write all of this, let's just write if not equals nil. I mean, how big of a deal is that?
Yeah.
So it's useful to go through that cycle sometimes, when you're working on stuff by yourself and you're just thinking, I can ignore the error here, and think to yourself, well, why? What am I assuming must be the case if I can safely ignore the error? And is it more trouble to document that assumption or just simply to check it? I prefer checking it because I could be wrong about my assumptions, and I frequently am. So that's great. So you're already making big improvements, which is no more than I expect. So that's great. Better tests already, so we can do exactly the same thing here, can't we? Yeah. We need a game. We can't do anything otherwise. So what's the next thing we should think about in the test?
So we have an initial velocity.
Yeah.
And after running the update function plus something, our initial velocity plus this should be equals our God.
Yeah. In fact, so we're sort of thinking about the question, what's our want, aren't we?
Yeah.
It's always how I approach tests anyways, to start off by thinking, what do I want to happen if the function has worked. And I could say, well, so what am I going to do in the test? I have a game with initial conditions. I'm going to let it evolve for 1 game tick, let's say, 1/60th of a second, or whatever it might be. In fact, the game tick right now is just user enters input. So probably not 60 times a second, but that's where we'd like to be, is we would like the game to run on its own clock, wouldn't we? And have the user interact with it in real time.
Right.
More accurate simulation. So, but for now we're saying, so we have the state, we'll let it evolve to the next state based on its numbers, and we know what they should be, because we're at least amateur physicists. So we can say, so we could say our want is a game with a certain config, couldn't we?
Yeah.
It's like we want one of these, but these numbers will be different.
Right.
But that doesn't actually feel quite right to me, because this, although this is everything that's in the game right now, we can imagine more, can't we?
Exactly.
Suppose we were recording the history of this game, for example. We might have a history writer, which could be a disk file or something like that. Or all sorts of other state about this game. Player's name, for example. Player avatar. So a game doesn't feel quite right. What we're really interested in is sort of the world state, isn't it?
Yeah.
Suppose we had... It almost sounds like we're talking about a separate field within game, doesn't it?
Yeah.
Suppose it was game.state, something like that.
So
Okay.
it could be a function that returns just a couple items.
Yeah, here we go down the refactoring hole. But that's okay. So we're saying we have a game and we want something like lambda.state, let's pretend. Grab these numbers. We can work out by thinking what the numbers should be, can't we? After 1 tick, we're descending at 100 meters a second, so our altitude should be 0. Velocity will have increased by the amount of gravity, won't it?
Yeah.
So we speed up as we descend, so that should be 110. Gravity won't have changed, unless the masses of the moon or the lander have changed. Now, if we have fuel, that would be the case, wouldn't it?
Yeah.
But we don't have fuel yet, so let's leave that as it is. And thrust, we can leave it where it is, can't we? We've already built the machinery for updating the thrust and checking that, and it works, so that's fine. All we're really testing is, can we evolve these numbers correctly? So that's looking good, isn't it? We have our want. Let's get our got.
But the thrust is not going to increase after the first direction.
Yeah, that's right. So we're saying, given no input at all from the player, the lander should just descend at a rapidly increasing velocity, shouldn't it?
Yeah.
And that's what the test says. So we know the initial conditions, we know the end conditions, and then we just evolve it. So suppose we just call UpdateWorld. But that's not quite right, is it? Because we don't want UpdateWorld to have to return the state. The state is in the G, isn't it?
Right.
We're saying it's a property of this particular game we're playing that its world is in a particular state. So instead, let's call UpdateWorld and then say got is what? G.state. Okay, and we know what comes next. Thank you, VS Code. That wasn't what I wanted at all. This is always the same. And let's use comp equal because they're structs, so it will be nice to see a diff, for example, if those structs get very big. So there's our diff. Good. We have some issues, so we don't have a state type yet, TBD. We don't have UpdateWorld, that's what we're doing. And we don't have a state field, so we can fix all of those, can't we? So, suppose, yeah, the linter is in a real mood with me at the moment, because I haven't documented any of these, and you know why not?
Yeah.
Because they're not finished.
It's going to change. Yeah.
If you look at any Go program in the world, you'll probably find something like, you know, show world state, yada yada yada, and you're like, well, that doesn't match the function at all. And the reason is they wrote that first, and then they changed this a bunch of times, and they forgot to update the comment. So we're way too smart for that, because we're engineers. So we're going to get everything settled, finish all the refactoring, and then we'll add some docs.
Yeah.
So, okay, so we've said there's a state struct, so it's some kind of struct, and in fact it's just these numbers, isn't it? So let's pinch that from game. Now what's in game?
The state.
Yeah, that makes sense, doesn't it? We want that to be exported because we need to check it in the test. State. Can't go wrong with that. Or we could call it current state or something like that, couldn't we? But we know what this means. I just want to take a moment to tell you about a series of ebooks I'm writing for Go beginners called For the Love of Go. In book 1, Fundamentals, I show you how to write tests in Go and how to build programs test first. In book 2, Data, I tell you all about variables and values in Go and data types like slices and structs. If you're new to programming or just new to Go, I'll show you everything you need to know to start building fun and useful projects. Go to bitfieldconsulting.com/books and enter Code Club at the checkout to get 25% off now. So, fine. So now we have to update new game because these are no longer fields on the game, they're fields on state, but that's alright, isn't it? We can do that. That just becomes a state literal.
How do you move the line down? I always forget.
Alt arrow keys.
Okay.
So that's handy. Great. Any more whammies? Yes. Display state now sounds like a method on state, doesn't it?
Yeah.
Although, yeah, and it takes a writer. That also feels kind of wrong to me. Like, it feels like the writer is a property of the game, doesn't it?
Yeah.
You could imagine displaying a bunch of things. What are you going to do? Pass a writer to all of them? That seems like a waste of time. But let's just say it's a method on game that takes that for now. So this is pretty easy. This is definitely not how it's going to be in the end, but that's alright. Same thing here. Okay. Issues dealt with there, so let's go back here. So a couple more issues. Okay, UpdateWorld still doesn't exist. It's alright, we'll get there. Okay, let's write UpdateWorld. First question, is it a pointer method?
Yes.
Yes, it is, isn't it?
Yeah, we are going to modify that.
Anything with a name like update sort of implies that it's a pointer, doesn't it? Because we want to modify it. We actually had this bug in the last episode, which you might have seen, where we wrote read thrust as a value method. We read the thrust and set the thrust, and then threw it away.
Yeah.
Because we were a method on a value of game. So we were a bit puzzled about that for a while.
Yeah, and when I was watching, I was saying it's a pointer.
Yeah,
It's a pointer there.
I know. And when I watched it back on YouTube, I was thinking the same thing. But I think that's actually quite nice because one, it proves this is not sort of fixed in advance. We're really coding this from scratch and making mistakes. And the other thing is we make mistakes.
Yeah.
You know, we're both relatively experienced programmers, and this is just normal.
Yeah.
I wouldn't say I'm unusually dumb as a programmer. I'd say I'm probably median dumb, you know. So I'm making about as many mistakes as a professional engineer would expect to make. And that's great. So people watching it were thinking, hey, I make mistakes too. I'm at the same level as these guys. So so we don't take any parameters and we don't need to return anything. That's nice and easy. We already have the code in some form, so let's grab it. Here it is. We're really just rearranging the deck chairs on the Titanic, aren't we?
Yeah.
So, not quite right yet, because it's state. So this is feeling a bit awkward that we have to keep putting state everywhere, but we may decide this is just a method on the state, something like that. Okay, fine. Are we ready to pass the test yet? I feel like we're compiling, aren't we?
I think there is one missing
Oh.
in the render.
Yeah, that's fine. So, same thing here. Good. Trailing comma, thank you. That's nice to have. Some issues here, but that's okay, we're still refactoring. Let's give it a try. I'm feeling confident. Yes, that's all good.
Yeah.
Let's just fake it to make sure we're not just writing a null test. It's easy to do.
Cool.
Great, okay. So this is what we'd see if we genuinely had a bug, which is good. Excellent. So we can now complete that refactoring here, can't we? So the aim is basically we started with a working game, we're moving everything into a package with tests, and we want to get back to a working game, and then we're going to do the fun stuff. So we had to eat our vegetables before getting onto the steak, if you like.
Yeah.
So we can fix a few little issues here. This is annoying to repeat. That's velocity. Good. Okay, any more whammies?
No. 0 warnings according to this code.
What's this about?
Just showing the difference.
Alright. Okay, good. Let's give it a run. I'm excited. We haven't played this game for a while, so I hope it's as fun as I remember. It's alright so far. So we start at 100, descending at 100. If we do nothing, we'll hit the ground next turn, won't we? But we'll be travelling too fast, so we want to do a gentle touchdown, like the Chang'e lander. So let's say, so if we said 100 here, then we should just be hovering, shouldn't we? So let's say 90. Oh, we landed at 20 meters a second.
Because of the gravity.
Yeah, that's right. So let's just try again, see if we can win. So let's say 100. So yeah, I forgot to account for gravity, like in those old cartoons where you run out over the edge of the cliff and then you go, gravity! Excellent. Okay, we won. That's really good. So I feel like we're in a good place. So this is a good commit point because I could imagine doing something I can imagine going down a refactoring hole now and ending up with something broken. So let's say got game working again. Yay! Excellent. Okay. So that's really valuable, what we've done, and we now have quite a coherent sort of picture of how everything works, don't we? And we've got some solid machinery in place for doing more things. Now, I think another of the BIT commandments is thou shalt not have to do comments in code. So I want to get these out and put them, should we put them in a README file for now? The reason I don't like to do comments in code is primarily because nothing ever happens about them, does it?
Yeah, usually no.
I mean, if you search for to do on all GitHub repos, you'll find lots and lots of them where the person genuinely thought this is going to make me do this at some point in the future, but for whatever reason it didn't. Because the bit they got wrong was they were thinking at some point in the future I'm going to sit down and read through all my source code, or I'm going to grep for the word to do, and I'm going to do all of those things. And no doubt they genuinely intended to do that, and then life happened. And it just went by the board. So use a real project management system, you know, whichever one you really use for your software. You have presumably some kind of backlog management or some sort of issue tracker, however you want to do it. This stuff belongs in there, doesn't it? Like, you have real issues and then you have your to-dos. If you have a to-do comment, to me that's like saying this isn't quite important enough for us to really create a card for it or create an issue. It's just something I couldn't be bothered to do now. So the problem is then that just never happens. So either do it now or put it in your real project management system. I'm not telling you, you understand. I'm telling myself as much as anybody. So let's pretend we have a real project management system, and for now it's just in our README. So, with your engineering brain on, for example, let's think about what would be logical to do next with this. If this was your project, would you be looking at it and thinking, the first thing I need to do is X? What would it be? Do we need to refactor the package or the tests, or improve the main.go and move more stuff into the package, or should we be working on features, or what should we be doing?
I would take a time in refactoring the main.go this year, like, see if there is something that we can improve.
Yeah, that's very good, because you could have said, let's do graphics. And I would be 100% behind that. I don't think there's a right answer, it's just different ways of thinking about it, isn't it? But we also know that there's no point building on a foundation if it's going to change and shift around, is there?
Right.
We want to sort of get this reasonably solid before we start playing with it. So we've said in previous episodes that you know, in Go we're always writing some package, not package main, that doesn't count. If all you're doing is writing package mains, you may as well write shell scripts. Not that there's anything wrong with that. But the point is, we want to create reusable libraries. Maybe we're the only people who will reuse them, that's fine. But we would like the Lambda package, for example, to be the core engine for our Lambda game. And one really useful way to think about that, which you're already familiar with, is to think about how might this be used. You know, in what different situations could we imagine this game logic being used? We have a CLI right now, so you know, the game is supposed to be run from the terminal. It talks to the terminal, reads from the terminal. But clearly we can imagine other things, can't we? We could imagine a web-based game, for example.
Yeah.
And we already started thinking ahead to things like the game object to make ourselves concurrency safe, which would be important. And we also decoupled the terminal from our logic, didn't we? Which is quite important. Anytime we write a Go package, it has some kind of input and output, or there's not much point to it. And so the first thing we do is usually give it I/O readers and writers to talk to instead of just talking straight to the terminal. So we could imagine the graphical version of this game, for example. We'd probably use some kind of library because I don't fancy interacting directly with macOS. That's, you know, that's a bigger manual than I care to read. So I'm sure someone's written a nice little Go library that just like create a window, draw a pixel, draw a sprite. In fact, I know there is such a library, it's called Pixel, and I'm quite looking forward to trying it out. But then you're thinking, okay, so if we have a GUI, how does this change? So we still have a game object, it still has state inside it, it has some way of displaying its state. Now that's graphical rather than terminal. It has some way of getting the control input. We're probably still reading the keyboard, but now there's no terminal because we're a GUI app. We'll still be updating the world and we'll still have some way of detecting the end of the game. So all of that stuff, and we'll have this loop, won't we?
Yeah, so the only thing I was envisioning was like try to remove this for loop.
Yeah, absolutely. So what we're saying is all of this stuff is needed regardless of what the front end for our game is, web, GUI, whatever. So this doesn't belong in package main, does it? Because this is game logic. So this loop is going to be there, just as you said. The end of game detection is going to be similar, set up the stuff. So we can imagine replacing all of this, or all of this, let's say, with something like g.run, you know, and that's it, kind of thing. So that all of, we'll be passing a few things in here, I'm sure, or maybe here. And we could imagine maybe there's like new terminal game, new GUI game, new web game, whatever, but the core logic would be the same. So, oh no, I lost all the code. Can I undo enough? Yes, I can. It's all in Git anyway, but
yeah,
it's fine. So yeah, so I think that's so for next time, our provisional plan is sort of what you said, isn't it? Move more of this logic into the package so that we can basically call something like g.run, and we would do that by writing a test for run. So we could imagine, like the game session that we just played for real, we could imagine automating that, couldn't we?
Yeah.
So, and we already have all the test machinery to do that, like bytes buffers that contain the user's input. Maybe run the game for 2 or 3 ticks just to make sure all of that works. And then, you know, we might have a happy path test, you know, where you land successfully, and a sad path where you crash. Test those behaviors. So that's great. So we will park that for next time, and it only remains for me to thank you for your assistance today. It's been great.
Oh, it's my pleasure, sir.
Wonderful episode, and I will see all of you viewers at home next time. Bye-bye.
Bye now.